blowing it. Okay, pinned. All right, cool, I'm pinned. So we were factoring x squared plus 7x plus 12, and we're looking for numbers that add up to the middle term 7 and multiply to the last term 12. So I should actually really point out, we're really looking for numbers that multiply to 12 times 1. This times this. But when it's 1 there, we don't really sweat it. And then the easy way to do this is just say, okay, this is going to equal x plus 4 times x plus 3. That's kind of it. And the reason that works is because if you multiply this out, you get x squared, you get a 3x, you get a 4x, and 4 times 3, you get a 12. And 3x plus 4x is 7x. So that's why you're looking for numbers that add up to this middle term, because they're going to end up adding here and multiply to this last term. There is kind of a longer way to go about this, and we're going to actually see this when we have more complicated examples. What you can also really do instead is, instead of actually going straight to this, you can take this intermediate step where you say, oh, this is really x squared plus 4x plus 3x plus 12. And then you can do what's called factoring by grouping. So factoring by grouping is when you have an even number of terms, you can factor out a common factor from each pair. So this first pair, both things have an x, so I can factor out an x. I'm left with an x plus 4. In the second pair, each thing has a common factor of 3, and I can factor out a 3, and I'm left with an x plus 4. And then if the remaining things are the same, you can then factor that out from both of them and have x plus 4 times the remaining x plus 3. I don't think you need to do it this way for these simple ones where you just have a 1 here, but you definitely can.
I have a quick question.
Go right ahead.
So essentially, whenever we have a coefficient for the a value, do we have to multiply a times c coefficients?
Exactly, and we're going to get there very shortly.
Okay.
So yeah, so I should point out that, right, so this is for factoring. Right, we are factoring something of the form ax squared plus bx plus c. So whenever someone says a, they're usually referring to the coefficient of x squared. When they say b, they mean the coefficient of x, and when they c, they mean the constant term. So yeah, so when we're looking for things that multiply to 12, we're really looking for things that multiply to 12 times 1. Excellent question. So let's look at a few more examples. Well, actually, before we look at a few more examples, I want to point out that some of the questions on the homework, which I haven't posted yet, I will definitely get it posted by the end of the regular, like by 4 or 5 o'clock today. I'm almost done writing it, but I haven't quite finished. So some of the questions ask you just to factor. And so if you're asked just to factor, then this would be your final answer. X plus 4 times x plus 3. On the other hand, some of the questions ask you to solve an equation. So I could ask you to solve the equation x squared plus 7x plus 12 equal to 0. And if we're solving this equation, we're going to solve it by factoring. Now, that's the only way, but it's the way we're going to use today. So I would first factor. We know it's going to factor as x plus 3 times x plus 4 equal to 0. And then we're going to set each of the factors individually equal to 0, because we're going to use what's called the zero product property rule, or the zero product property, I guess. You don't need property and rule. The zero product property that says that if two things multiply to 0, then either one of them has to be 0. So we're going to set this one equal to 0, and then we're going to subtract 3 from both sides and get x equal to negative 3. We're going to set this one equal to 0, and then subtract 4 from both sides to get x equal to negative 4. I'm perfectly okay with you skipping this step and jumping straight to saying x is negative 4 or x is negative 3. So just be aware there's a difference, right? If you're asked to factor, I just want the factors like this. If you're asked to solve, you're supposed to find what x is equal to. And usually there will be two solutions, although occasionally there might be just one. Really tight over here. One sec. Okay, come on. And yes, please feel free to jump in with questions if you have them. Ah, so many pens. Too many pens on my table. I got this whole other table. I should use that. Good job. Okay. So I'm just going to show you some examples. Like I would like to factor. What have I got here? I have x squared minus x minus 6. And so again, right, I'm looking for numbers that multiply to 1 times negative 6, which is negative 6, and add up to negative 1. It's really, really important for all of these problems that we be careful with our signs. The negatives are important. So I want to multiply the negative 6 and add it to negative 1. My numbers are something with 2 and 3. I think it's negative 3 and positive 2. And so then those are the numbers that are going to go in my expression, right? I'm going to have x minus 3, x plus 2. Just to point out, so one thing to kind of be aware of is that if you're solving this equation equal to 0, you usually get the opposite of the numbers that are the numbers you find here. So these are the numbers that go in the expression when I factor it. But if I was solving this, if I was solving x squared minus x minus 6 equals 0, and so I was factoring it as x minus 3 times x plus 2 equal to 0, I would end up getting x equal to positive 3 and x equal to negative 2. So that's what we've got there. We can also check our answers, right? If you're ever unsure if your answer is this, so I should say, if we're in the part of the problem where we're finding a solution like this, but we're solving this equation equal to something, if you're ever unsure about your answer, you can always plug it back into the original. If I plug in 3 squared minus 3 minus 6 is 9 minus 3 minus 6, which is 9 minus 9, which is 0. If I plug in negative 2 squared minus negative 2 minus 6 is equal to negative 2 squared is positive 4, minus 2 is plus 2, minus 6. 4 plus 2 is 6, 6 minus 6 is 0. So both of those are solutions we plug them back in. I don't ever need you to plug them back in for me. I'm not going to ask you to do that, but I just want you to know that that is something you can do if you're not sure if your solution is actually a solution. Another thing you could also do is graph it using Desmos and see what the x-intercepts are, because that's another thing you could think about as we're finding the x-intercepts of this graph. There are lots of interpretations of what we are doing. Okay. So let's do some quick ones here. So we're going to factor the following. These next 4 are all kind of the same, but all different. So x squared plus 5x plus 6. What I want to kind of say is that when the coefficient here is just 1, I don't need you to show me a lot of work. I want you to be able to factor this probably just in like one step, really. I'm looking for numbers that multiply to 6, add up to 5. Well, clearly that's 2 and 3. So my factor is going to be, we're going to factor as x plus 2 times x plus 3. People use like a diamond or something. I've never done that in my life, so I'm not really sure how it's supposed to work. I know you like, I couldn't do it if I want. I know you do like 6, 5. I really like multiply, add. You can do that if you want. I'm kind of clueless when it comes to that. I'm not gonna lie. I know it's supposed to work something like that. As long as you understand what you're doing, that's fine. So here we got this one, and then let's look at a couple more. We've got x squared minus 5x plus 6. So here I'm looking for the same sort of thing, except now I want to multiply the 6 and add it to negative 5. So I'm going to get the numbers being negative 2 and negative 3. Right? Those are the numbers that multiply to positive 6 and add up to negative 5. Something I want to say here is that if we were setting this equal to 0, these wouldn't be our answers. But we're not, we're just factoring. This is going to factor as x minus 2 times x minus 3. Let's go to the other side because I want to show you something else. We're going to come back, we're going to make an observation after the next two. The next two are going to be very similar as well. All right, come on. So now I'm going to have x squared plus 5x minus 6. Again, we're still just factoring. So now I'm looking for numbers that multiply to negative 6 and add up to positive 5. Those numbers are thinking are 6 and negative 1. So I'm going to have this factor as x plus 6 times x minus 1. And really, what I've seen some people do when they do problems like this, really the middle term is the thing people aren't sure about sometimes. I know if I multiply this out, if I FOIL this out, I'm going to get x times x is x squared. I'm going to get 6 times negative 1 is negative 6. But I'm not exactly 100% positive about the middle term. I definitely see people do this to check just the middle term. There's a 6x. There's a minus 1x. And 6x plus negative 1x is giving me positive 5x. So it checks out. And let's see here. So yeah, so that's it. Oh, and then finally, I also want to look at this one. X squared minus 5x minus 6. So I'm going to factor this one. Again, I'm looking for the same things. So now multiplying to negative 6 and then adding up to negative 5. And what we're going to see here is that our numbers here are negative 6 and positive 1. In fact, they're exactly the opposite numbers of these. So this is equal to x minus 6 times x plus 1. The observation I want to make for you all is that if the polynomial, or the quadratic I should really say, if the quadratic is exactly the same, except the middle sign, the coefficient of b is the negative of what it was before, right? If one's positive and one's negative, it's going to factor exactly the same way, except the signs are going to switch. Here it's plus 6 minus 1, here it's minus 6 plus 1. And the same is true for the one we did before. Here, this was x squared plus 5x plus 6. This was x squared minus 5x plus 6. And the signs exactly changed. Here was x plus 2 times x plus 3. Here it's just a minus 2 and a minus 2. So that's something nice to be aware of, because if you're factoring, like if someone said, for example, if I was the kind of person who was going to give you these two problems, say to factor x squared plus 8x plus 12, is that right? Yeah. And then also to factor x squared minus 8x plus 12. You could say to yourself, well, he's really only given me one problem to do. Because once I do this one, I will know the answer to this one. Here, I want to multiply to 12 and add it to 8. So let's see. Numbers that multiply to 12, 1 times 12 does not add up to 8. 2 times 6, that does add up to 8. So right, those multiply to 12. 1 plus 12 is 13. 2 plus 6 is 8. You can also look at 3 and 4. clearly this is the set of numbers we want. So we're going to factor this as x squared plus 8x plus 12 is equal to x plus 2 times x plus 6. And now here's what we get to kind of know automatically. Here we were looking for numbers that multiplied to 12 and added up to positive 8. And positive 2 and positive 6 were those numbers. Here, we're looking for numbers that multiply to 12 and add up to negative 8. So negative 2 and negative 6 is going to fit the same bill, right? They're going to multiply to positive 12. They're going to add up to negative 8. So here, this is going to factor as x minus 2 times x minus 6. So the nice thing here is that if you see that just the coefficient of b, if that's the only thing that changes signs, then you know how they both factor by just changing. By just changing those signs. All right.
I have a question.
Yeah, go ahead.
Probably like really like general and easy, but like does it matter the way the question or like the answer is like written out? So like let's say I just got x plus 6 and then x plus 2, like it just like the reverse way of what you wrote.
So for any of these problems, the order of multiplication does not matter. And that's true for most of mathematics, right? When you multiply two numbers together, doesn't matter if you do 5 times 2 or 2 times 5. Same is true for these. It does, I will just mention very briefly, if any of you are taking the 17 series, eventually you will probably be dealing with matrix multiplication. And for matrices specifically, order of multiplication matters. But for most things we usually encounter, order of multiplication doesn't matter. You can do this times this, or you can totally do this times this. Either way is correct. Same deal here. It would also be perfectly fine to write it as this. You do not need to write both. One answer is sufficient. Okay, so yeah.
I have another question.
Yeah, go ahead.
So, you know how you did the x squared minus 5x plus 6, and then you did that one again? So the first time you got x minus 3 times x minus 2, and then the second time it was minus 6 plus 1. Does it matter like when you do it, if there's different ways to do a single one?
So here's something that's always true. There's only ever one way to factor a distinct polynomial. What I imagine happened is, so I'll just write down those other two again because they were all actually different. So the other two that I had before were x squared minus 5x, x squared plus 5x plus 6. That's going to factor as x plus 2 times x plus 3. And then we also have x squared minus 5x plus 6, which is going to factor as x minus 3 times x minus 2. Or I should do the same order. Again, order doesn't really matter, but I'm going to do the same order. So all of these are different. And the reason I actually did these four specifically is because people, myself included, often make a mistake doing them. So whenever you've got an x squared and you've got a plus or minus 5x and a plus or minus 6, 1, it's always going to factor. 2, you have to be careful because sometimes, so if it's a minus 6, you're going to get 6s and 1s. If it's a plus 6, you're going to get 2s and 3s. And then
so there's only ever one like way to factor it?
There's
only ever one way to factor it?
Yes, there's actually a theorem. It's actually called the fundamental theorem of algebra, I believe, that basically says there's a distinct way up to like a constant of factoring a polynomial. So yes, every different polynomial can only be factored one way. It's a really, really good question. So I just want to say again, each of these is different and each of them factors differently. Yeah, that's a really, really excellent point. Very good question. Thank you so much. Okay. Yeah, Something else I want to say about this? No. I will say, just be careful with these ones, right? Because it's really easy to mistake things, right? You're like, oh, if I multiply to 6, it's got to be 2 and 3, but it doesn't have to be 2 and 3. It could be -6 and +1, or +6 and -1. So just be extra careful. And that's why it's super duper important to pay attention to the sign, right? Don't think of having 6 here. Think of having a -6 that we have to multiply to. Okay. So then we solve equations. So we can solve, so the only difference really, well, I should not say that exactly. So when we solve equations, we're going to factor until tomorrow. We're going to start talking about the quadratic formula. But when you solve an equation like this, while there are many ways to solve an equation like this, there's kind of a hierarchy of what's best. And in my opinion, the hierarchy is first, you try to factor it. If it's easy, great, you're done. Second, if it's not easy to factor it or impossible to factor it, you jump straight to the quadratic formula. There are other things you can do, like completing the square and some other weird stuff, but those are really the two things that will, one, be easy if it works, and two, always work if the easy thing doesn't work. And I think that's all we really need. If there are other methods you really like, that's perfectly fine. You should use them. But I'm trying to present basically the way that I think is going to be the fastest and still easiest to understand way of solving an equation like this. Today, we're just factoring. So I'm going to factor this. I'm looking for numbers that multiply to 1 times 4, which is 4, and add up to 5. Well, those numbers are 1 and 4. That's again, I will point out, just because some people, in fact, we are going to do this shortly, some people really like to think about this as x squared plus 4x. Let's do it. So, sure, plus x plus 4, right? This is the same. 4x plus 4 is equal to 5x. Where'd you go, red pen? And then we can factor this by grouping. From x squared plus 4x, I can factor out a common factor of an x. From x plus 4, well, 1, pun about to be understood and intended, 1, I can see that that's the same as that, so I don't really want to factor anything out. And 2, I can factor out a 1 is the only thing that actually factors out. And then from each of those, I can factor out an x plus 4. And I'm left with an x plus 1. That's another way of factoring this, which we're going to use more once we have a coefficient that's not just 1 for a. Either way, we set x plus 4 equal to 0, and we get x equal to -4. We set plus 1 equal to 0, and we get x equal to -1. And those are our two solutions. A quadratic equation or a second degree equation like this can only ever have two solutions at the most. Okay. We'll do a couple more. So let's go over there. So sometimes people like to make it a little bit more challenging by not writing everything equal to 0. So for example, you have something like x squared equal to 5x plus 24. And we really, really, really want, except for in rare situations, to have everything equal to 0. So I want x squared, so I'm trying to solve. Notice we're solving something, we'll always have an equal sign. If we're factoring, there won't be an equal sign to start out with. It'll just be like factor this thing. So I'm going to solve this. I'm going to subtract 5x, subtract 24. That's equal to 0. And now I'm looking for numbers that multiply to -24 and add to -5. So I know one of them has to be negative and one of them has to be positive, right? If you're going to multiply to a negative. And the bigger one should be negative because I'm adding up to a negative. So I'm thinking like negative 24 and 1, or negative 12 and 2, or negative 8 and 3, or negative 6 and 4. Those add up to negative 23, those add up to negative 10, those add up to negative 2, and those add up to negative 5. That's the one I want. So I want x minus 8 times x plus 3. 0. So really, when I'm trying to factor something like this, I'm kind of limiting myself to all the ways I can multiply to this, and then I check how those add up to see how I get to add up to this. I really left off 4 things that I knew weren't going to work, because we could have also tried 24 and negative 1, 12 and negative 2, 8 and negative 3, 6 and negative 4. But I knew that since this middle term was negative, the negative one had to be the bigger thing, so I didn't even look at those. So here, we have x minus 8 equal to 0, which gives us x equal to 8, and x plus 3 equal to 0, which gives us x equal to negative 3. Let's look at a few more examples. Let's look at a couple examples that are often almost too easy that they throw people off. So let's look at one like this. Let's look at x squared equal to 6x. So you could probably solve this one in what I would call maybe the wrong way, by dividing both sides by x. If you divide both sides by x, you would get x equal to 6, which isn't wrong, but it's not fully correct because you're missing a solution. What we should do is bring everything to the left and then factor. Now this is kind of the one case where it doesn't factor like usual. Right? We're not like doing 2 things that multiply to whatever and add up to whatever. Here, since we're missing the constant term, everything has an x and we can just factor out an x. And factor out an x, I'm left with an x minus 6. So I get x equal to 0. And I get x minus 6 equal to 0, so x equal to 6. The other one that can sometimes throw people off is something like x squared minus 16 equal to 0. This one you could solve without factoring. I'm going to factor it, but then I'll also point out how you could solve it without factoring. So I'm going to factor this. I'm looking for numbers that multiply to negative 16. And add up to 0x, or they don't have an x term. This is x squared plus 0x minus 16. Well, the numbers that multiply to negative 16 add to 0x or add to 0 are 4 and negative 4. So this is going to factor as x plus 4 times x minus 4 equal to 0. If we multiply that out, we would definitely get x squared plus 4x minus 4x, and those would cancel, and then minus 16. And this gives us x equal to negative 4 and x equal to positive 4. This one type of equation, this one type of quadratic equation, is probably the only type that we can solve without really factoring. You could totally solve this by just saying x squared is equal to positive 16, and then x is equal to plus or minus the square root of 16, which is plus or minus 4. If you see a question like this on the homework, I would still prefer you to actually factor it, because it is good to be able to factor this kind of expression, but it is also solvable, but without factoring.
What if it was x squared plus 16 equals 0?
Then there would be no real solutions.
So I just write no solution?
Yes. So at this point, I'm not going to ask you questions that don't have solutions, but that's a very good question. If you're trying to solve x squared plus 16 equal to 0, there's no real solution. later on, not in this class, I don't think, but in a future class, you might talk about complex or imaginary numbers, and then this equation does have imaginary solutions or complex solutions. But that is not the thrust of what we were talking about today. So, good question. We might talk about it tomorrow. We'll see how the timing goes. Yeah. And I should just point out, the reason why there's no real solution is because if you try to solve this, x squared equals negative 16, x equals to plus or minus the square root of negative 16. The square root of a negative number is imaginary, right? If you were actually talking about imaginary numbers, we would say that this was equal to plus or minus 4i, where I is the imaginary square root of negative 1. But don't sweat this. I'm not asking you about that for sure. If you happen to find one, so I try to check my work. That's why it's taking me a little bit longer to make sure to post this 100%, to making sure that they all actually factor correctly. But if you find one that doesn't seem to have a solution, send me a message and I will make sure it's correct, or I will tell you what you might be doing wrong. All right. How much time? I should. So there's lots of examples in the notes, but I'm going to move on to when you have a coefficient that is not 1. So I want to factor. Factoring ax squared plus bx plus 1, c, when a is not equal to 1. So, for example, I want to factor, not u, I want to factor 2x squared plus 13x plus 15. And as I mentioned before, there's a multitude of ways to do this. There's a method I've seen students use where they multiply everything by a and then factor it that way. I've never been good at that. The way I've learned to do this is to do the following. So a times c is 2 times 15 is 30. We're looking for numbers that multiply to 30 and add up to 13. Or more generally, multiply to a times c and add up to b. So can we think of some numbers that multiply to 30 and add up to 13? Yeah, 3 and 10. But here's the part where people get stuck. So I've seen people get to this and they're like, great, you got 3 and 10. And then they say it's x plus 3 times x plus 10, which is not right. I know it's not right for a couple reasons. One, if I multiply it out, x times x only gives me x squared, and I have a 2x squared. 3x plus 10x does give me a 13x, but 3 times 10 gives me a 30. These are not the same. This is not what I actually want to do with that 3 and that 10. What you want to do with these two numbers that you find that add up to 13 and multiply to 30 is rewrite 13 as 3 plus 10. So that 2x squared plus, and you can do it either way. I'm going to do it as 3x plus 10x plus 15. That's how we want to rewrite this. And then we're going to factor by grouping. So 2x squared plus 3x, I can factor out a 2x, just an x, actually not a 2x. I'm left with a 2x plus 3. 10x plus 15, I can factor out a 5. And I hope that I'm left with a 2x plus 3. You have to end up with the same thing in each of these parentheses, otherwise we've gone the wrong direction. And then from each of these, I'm going to factor out this thing that's the same. So I'm going to factor out the 2x plus 3, And I'm left with an x here and the 5 here. So this factors as 2x plus 3 times x plus 5. And this process, as long as the thing factors, this process will always work. The bummer is that not every quadratic factors. There are lots of quadratics that don't factor. And so what I will tell you is if you find yourself spending a lot of time trying to factor something, you should stop. You should stop factoring if it doesn't factor or if you don't know how to factor, and jump to using the quadratic formula. Now I should point out, that's only good advice if you're trying to solve an equation. If the question actually says factor this thing, and that's all we have to do, then it should factor. But if the question, like this next one, says solve, well, then we can try factoring, or if we don't like that, we can try the quadratic equation tomorrow. So I want to solve 3x squared equal to 6 minus 7x. And just like before, I'm going to put everything on one side. And here's the thing you want to do. You want to put everything on the side where the coefficient of x squared is positive. You can have a negative coefficient of x squared. I find it especially challenging to deal with that. So I always make it work so that my coefficient of x squared is a positive coefficient. So I'm going to bring everything to the left. So I'm going to have a 3x squared plus 7x minus 6 equal to 0. A times c is 3 times negative 6, which is negative 18. I'm looking for numbers that add to negative 18. That's not right. Add to 7 and multiply to negative 18. So since I'm multiplying to a negative, they have to be opposite signs. The bigger one needs to be positive so that they add to a positive. So I could have 18 and negative 1. That adds up to 17. That's not right. I could have 9 and negative 2. That adds up to 7. We're done. So then we have to remember what we're doing with that, right? We're saying, oh, 7, that is 9. I should say 7x is 9x minus 2x. And then it's the same kind of story over and over again. So I should say, if you can do this part, right, if you find numbers that multiply to a times c and add up to b, then the rest of this should always work out correctly. You should factor by grouping in the right way. I'm going to factor out a 3x here. You always want to factor out the most you can. So I factor out a 3x, I'm left with an x plus 3. Okay. From this second part, can someone tell me what I can factor out from this?
A 2.
You're very right. Now, I want to point out, if I factor out a 2, I'm left with a negative x minus 3. And those aren't the same. Thank you for the 2, by the way. The 2 is the answer I was really hoping for. And while 2 is something we can factor out, we should also think about what we want to have left behind. And if we see that we want to have left behind an x plus 3, I want to leave behind an x, so I should factor out a negative 2. So I really want to factor out a negative 2, so then I'm left behind with a positive x plus 3, because then these things look the same. So then I can factor out an x plus 3, and I've got a 3x minus 2 equal to 0. So here I get x equal to negative 3. Here you might have to work a little harder. If you set this equal to 0, add 2, so 3x equals 2, and then divide by 3 to get x equal to 2/3. Yeah. If you look at the notes later on, I also did this one by a method that's called guessing and checking. And guessing and checking is really time consuming. I kind of like, it works sometimes when things are nice, and I used to probably be more of a proponent of guessing and checking because it was like, oh, we can kind of eliminate things. But I will say this method, if it works, it works. Like if the thing factors, this will work. It can be sometimes challenging. Like, I don't know this example. So depending on the numbers, sometimes it can be harder than others. So let me show you a couple more examples, and I'll try not to go over today. Yeah, I'm gonna do. So let's look at this one. So 3x squared plus 8x equal to 3. So first of all, I'm going to bring everything over to the left. So 3x squared plus 8x minus 3 equal to 0. And you could try doing this one by guessing and checking, right? I know it's going to factor as a 3x and an x, because that's the only way I can really multiply the 3x squared. And I know these parts here have to multiply to -3. And there's only a few ways I can multiply to -3, right? It could be, let me look at my list here. It could be 3 and -1. I know I'm looking at my list because I want to do them in a certain order. 3 and -1, -3 and 1, 1 and 3, or -1 and 3. And here's the thing. You actually can't have a 3 here. Because if I had a 3 here, I could have factored out a 3. But I can't factor out a 3 from here. So if you can factor something out from here and you couldn't from here, they're not the same. I also can't have a -3. So it's either got to be 1 and 3 or -1 and 3. And let's see. So if it's that one, let's see. I get 3x squared. I get plus x minus 9x. And I get -3. So this is 3x squared minus 8x minus 3. Ah, so close. Here's where that thing I was saying before about the middle term being the wrong sign actually is important. I guessed this, and I was off by the middle sign. So if I just change my signs here, I know it will be right. So this actually becomes 3x minus 1 times x plus 3 equal to 0. And I know that's going to be right because the middle term is 8x, positive 8x. And then we would set each factor equal to 0. So 3x minus 1 equals 0, 3x equals 1, x equals 1/3. Or x plus 3 equals 0. The thing I most want to say about this, 2 things. Come on, brain, work. I totally lost where my brain. Oh, so what I want to say is this one isn't so bad to guess with because you have very limited choices, right? There's only a couple ways to multiply 3. There's only a couple ways to multiply to -3. On the other hand, and also you also could have done this one the other way, right? And I think I recommend wholeheartedly doing it the way we have been doing it. So let me give you one more example. We're not going to guess and check on this one. We're going to do it the long way, or I should say the consistent way. Let's do this one, yeah. So let's look at, where'd you go? Yeah. Sorry. 5x equal to 6 minus 6x squared. And so be careful here. This is definitely a question where I wouldn't go this way. I wouldn't say it's 0 equal to -6x squared minus 5x plus 6. I don't want a negative coefficient on x squared, so I'm definitely going to go this way and say it's positive 6x squared plus 5x minus 6 equal to 0. And this one is definitely not a good candidate for guessing and checking, because if we guess and check here, there's lots of ways to multiply to 6, and there's lots of ways to multiply to -6. So here instead, we should say that A times C is 6 times negative 6, which is negative 36. B is 5. So we're looking for ways to multiply the negative 36 and add it to positive 5. So, excuse me, I know I've got to have opposite signs because I'm multiplying to a negative, and the positive one's bigger because I'm adding up to a positive. So I'm thinking like, and I just start to go through the list, right? I'm not going to, I know what the answer is, but I'm going to say like, let's just go through the list. I'm going to do 36 and negative 1. That's a no. Or 18 and negative 2. Or what's next? 12 and negative 3. Or 9 and negative 4. And that looks like it's it. Because 9 and negative 4 multiplies to negative 36 and adds up to positive 5. So basically, as I'm writing down the ways that negative 36 factors, I'm thinking about what these each add up to. Okay, this adds up to 35. This adds up to 16. This adds up to 9. This adds up to 5. So this one, I'm going to rewrite as 6x squared. And now you can make either choice. You can either write plus 9x minus 4x minus 6 equal to 0. Or, I'm going to erase this over here so I can use this side. I know we're out of time. I'm almost done, I promise. You guys are like, this guy's a liar. He's almost always done all the time. Or we can do that. Either way, we'll get the same results, which is kind of nice. So once you figured out how to add up to 5x, it doesn't matter which way you write it. Let me show you. So here, factoring by grouping, I factor out the biggest thing I can, which is a 3x. I'm left with a 2x plus 3. Here, since I know I want to leave behind a positive 2x, I'm going to factor out a negative 2. I'm left with a 2x plus 3. I then factor out the 2x plus 3. I'm left with a 3x and a minus 2. On the other side, over here, factoring by grouping, here I factor out, let's see, a 2x. I'm left with a 3x minus 2. Here I factor out a 3. I'm left with a 3x minus 2. And then from each of these, I factor out the 3x minus 2. I'm left with a 2x plus 3. So I get the same factoring either way I do it. It's just the multiplication looks like it's flipped. Still the same deal. And so then in either case, we set this equal to 0. 3x minus 2 equals 0. Gives me 3x equals 2. Gives me x equals 2/3. And then 2x plus 3 equals 0. Gives me 2x equals negative 3. Gives me x equals negative 3/2. That's how we do problems like this.